Okay, so now what we're going to do is that after the placement we're going to start routing, and then now we are going to use something that we have already used before, and this kind of panel like or matrix like layouts, it is better to route either from top down or from bottom up. So we're going to do bottom up. We're going to start with the ground connection, same layer metal 2, and I'm going to use a width of 1, so there are at least 2 cuts that or 2 wires that are going to be connected. Absolute spacing 0.34, 0.34, that is okay. The twist will be in metal 1, and then I'm going to use to cover the pin with the relative width pin. And okay, we're going to run it here down, and then I see that the connection to the ground has already been done, but as I mentioned before, there are some things that I don't like. For instance, this connection to the ground, so we're going just to delete the gate connections very quickly. Okay, so we have disconnected these gate connections to ground, so we are happy with that. And now we are going to do something different. First, let's look if the connections have been connected nicely, and we see that yeah, there is covering the pin and the connection is going down, and we have two wires per connection, which should be okay. Now we are going to do something a little bit different, and we are going to use the create trunk topology, and this is very similar to what we did before, but now we can lay out several nets at the same time. Now what it is important is that as I mentioned before, the source should be connected first, so I'm going to pass these trunks here, and I want the source to come first and connect it as close as possible. So I put the ground on the top, and then the others really, they don't matter so much in which order they come. 1 micrometer, and the absolute spacing, that is okay. And let's see what happens when I route this one. Then yeah, we have grounds connected like this. Okay, now we have to do some manual work, because I don't like the gates to be connected down. All the gates should be connected to the metal top that I put on the from the beginning, so I have to do some manual work disconnecting the gates, so all the gates will be disconnected, and I have to do this before I put the next one, because when they see them connected, it will not try to make a twig, so I have to do it now. So it is a little bit of manual work, but it pays off, because when it is done correctly, the layout, it is automatic, and we don't have to worry about DRC errors. And the last one here, okay. And yeah, we can have a preview here to see how this is going to look, and okay, we make a small mistake. I mean, it is not really so serious. We can go back and fix it. As we see here, since we use the option to cover the whole pin 100%, now the gates are very large, and that is not very okay. So we're going to remove these ones, and also undo and remove this tweak. So we're going to do it again. We put here. So these widths are 0.34, so I rather do it manually, the configuration, instead of having the relative pin width that is going to make very large gate connections. I will put it like this, and then let's pass it again. Okay, and then I delete the gates. Save, and then now we can have a preview. Let's remove the. Okay, and now it looks very nice. The source and drains are connected to ground first, very close by, and then the drains are also connected. We see the output is here. The gates are connected to ground also nicely with short connections, and they are not very close to the drain and source, so there is not going to be DRC errors. And we have the configuration that we shall use for the other rows. So we keep it like this. This has not changed, it is exactly the same. Now let's move to the second, and then we have the second row. Let's delete these gates. We delete this one, this one, this one, this one. All the gates that are at the bottom, I will manually delete. This one, this one, this one. Okay, and that should be okay. We check, and then it looks nicely routed. Okay, we move forward. We do the same for the top, so it's the same configuration. Then we remove the gates. Okay, let's have a preview. So this looks okay. There are no overlaps or violations here, so that is fine. And yeah, then do a final here on the top. Okay, and now notice this. Even though there are not so many connections here, I will still keep it. I will still keep it the cells that are not connected And the reason for that is that I need the distances to be the same. So I need these distances to be exactly the same, so there is perfectly match. Okay, I will connect I can actually do the connection here on the top. That will not be impossible, but or I can defer it to do it in the layout. It really doesn't matter. That will not be any problem. I mean, we can do it like here. Ground one on the top, and pass it here. Let's see. Oh, now I realize I have not deleted this. I have to do some manual work. Remove the gate connections. This one goes here, goes here. Here. This one goes as well. And the last one. Now it should work. You see, there is no more gates, and then I use the last on the top. Okay, now it should be symmetric everything. Yep. Let's show only the layout here. So I'm fine. All the horizontal routing has been completed. The layout is symmetric. Distances are the same for all transistors and channels. So now I proceed to do the vertical connections, and we do exactly as we did before for the. We can use, if we want, we can use the trunk topology the same as we did before, and start collecting the currents in all sides, or we can use the single trunk. It really doesn't matter. What do you prefer? We can test now this one, and I'm going to collect with 2 micrometer all the currents, and then we start with the ground. Of course, the ground has to be as close as possible to reduce the source resistances. So I'm going to start with that one. Absolute spacing is okay. Let's see, starting with 2, and for the tweaks, they are not connecting tweaks right now, so I really don't care about this one. So let's see what happens if I try this one. Oh, I forgot. I need to change the metal. This has to go in metal 3, 2, and then it goes down to metal 2. I think this doesn't matter right now because they are not connecting to pins. So we try it, and then we see that it has been connected, and in this particular case, for this current mirror, maybe I really don't care much about the extra capacitance that happens when but the order is wrong. The ground should connect first to be a little bit better, to reduce a little bit of stuff. So it doesn't take me so much effort to go back and do it again. So I put this one here down, and the rest has not changed. This has to be 34, and then now I use it, and now the ground it is closed. So if I want, I can finish there, or the corners will be collected in this side, and that will probably be fine. I can also put it on the other side if I want to reduce this resistance. Yeah, but let's do that. Let's see. But now I will have to change the ground up, and then the other options are okay, so I can do that here, and then we see that everything it is connected. Okay, so we have connected both sides. Okay, so since we are connected in both sides, maybe we need to connect. We can take the currents from one side or from the other. I mean, it is something that we can decide a little bit later when we are doing the top connection. We can take it in from the left or from the right. Now the impedances that we have are a little bit lower. The resistance that we have, the series resistance that we have, because we are connecting the trunks in both sizes. Okay, something else that I can do here. Let's see how it looks when everything is connected. Looks nice, DRC free. We can add a big contact and an MPP word ring, or we can do that later during the final layout. So normally I prefer to do it later when I see how the other parts of the layout look like. Okay, so we are finished with this current mirror by now. Let me save it.